So hello everyone. Today I'm here I'm at this wonderful place called the Frontier, which is actually a co-working space slash innovation center here in Raleigh, North Carolina. And what's so special about Frontier is that you don't really need to be a member to become use their co-working. So anyone can come in anytime, use their open space which is downstairs, and just drop in and start working, use the meeting room, but you do have to book the meeting rooms. And on top of that space is where companies who have graduated from that co-working space probably move into our private offices where they all work on their own ideas. So today we are going to talk to Raj. Raj comes from India, Calcutta, if I'm not wrong, or he can share more, but as far as I know, he's from Calcutta. And he's like a leading expert in the US on big data. Very recently, he has written a book called Practical Big Data. It was published by the Pack Publishing House. So today, since I'm here, I thought, why don't I sit down with Raj and have a quick chat on big data and understand, why he wrote, what he does, his past, as well as learn more about big data. So with that, I'm gonna come to you, Raj. Raj, thank you for being here. Can you quickly introduce yourself, share your expertise, experiences? How did you end up where you are today, and what made you to write this book?
Sure. So thanks for the introductions, Sajid. I've been doing big data in the technical sense for at least the past, I would say, 10 years or so. Since I joined UBS Investment Bank working in algo trading or algorithmic trading. So I started out my career at IBM. I was still a freshman in college at the time. I was working with the Global Web Architecture Group. I worked a bit briefly for Philip Morris, working in Linux capacity planning, and thereafter moved into UBS in 2008 in the foreign exchange trading group. So the financial industry has been using big data, so to speak, for at least the last 20-25 years. And that is where I got my first introduction to what's called low latency analytics of large scale data sets. In 2013, I moved into a pharmaceutical firm called Purdue Pharma, where they had an initiative to build a big data platform. And one of the tasks I had was to sort of start from the ground up and build out an architecture that was going to be used to analyze very large-scale healthcare data sets. Now, the traditional industry uses Hadoop, Hive, HBase, and NoSQL technologies, which are all well and good, but then in finance, you also have some very niche tools that operate at sort of the hardware level. They're written in C or assembly, and they literally sit inside the CPUs in order to gain that kind of performance. So I developed a platform there which got quite popular, and thereafter some investors sort of spun out the group to create this new startup entity to bring the capability to the broader healthcare sector.
Fabulous. Now, for people who may not be familiar with what a UBS is, can you say what is who is UBS?
Sure. So UBS is a Swiss bank. They're based in, as you know, Zurich. Most people know that. They're both into investment banking as well as wealth management, so both principal trading as well as agency trading. Their foreign exchange group is extremely one of the most coveted groups in the industry. They are one of the market leaders trading. So the foreign exchange industry trades about $4 to $5 trillion a day, and UBS has about 10 to 12% of the market share. So on a per day basis, there's a huge volume that gets traded. They have other lines of businesses. It's the typical trading environment. And I was in Stamford, Connecticut, working on the trading floor for almost 7 years or so that I was there.
Okay, cool, great. Just wanted to kind of, so people understand, because not everyone watching it would probably know what UBS is offhand.
Right.
So let's focus. So you mentioned you've used big data for, it's a very popular term right now, but probably way before back then when no one really knew or understood what it is, except for probably the industries that were really leveraging it to come ahead. Now the question is, so you recently wrote this book, and here I am holding it up. If you can see it, so practical big data analytics. Can you share more about what led you to write this? What's your, what is this book about?
Sure, sure. So, um, since I've been doing this for many years, I got approached by certain publishers in order to produce a book on the topic. There's a level of ambivalence in the industry as to what big data really is. To someone who's using Excel, a 1 gig Excel file could be big data, whereas to, let's say, Google, a petabyte or a zettabyte could be big data. So it's a very relative concept, right? And then there are other nuances, like there are many different components. It's not just the technical aspect, because so you can analyze the data, but then what do you do as the next step? So big data or data science, more generally speaking, consists of, one is the technical aspect, which is handling very large-scale data sets, mining very large-scale data sets. The second part is machine learning, as to what do you do as the next step. Once you've mined the data, once you're able to access the information, how do you get insights out of that information? But all of these need to be supported by the business. So there are three main components, which is the technical, the analytics of the machine learning part, and the third is the management component. So these are pretty diverse areas in one sense, and another sense it's really not, because they're all interconnected. When you're launching a big data initiative within a firm, these are all, there are many different considerations you have to take into account. So the publishers wanted me to produce a book that's going to have like the breadth of big data rather than the depth. So by which I mean it's going to cover a wide range of topics without really going too deep into any of them, so as to give the overview of the field.
And I will also share that I did have a chance to read some of parts of the book, not the whole book. So, but however, one thing I really liked about the book is the way the chapters are structured. For someone, I've heard a lot about big data. However, for me to be able to take the chapter by chapter, I'm actually flipping through the chapters as I'm talking, is one thing I liked is like how you kind of show how to get started as well. Right. So I mean, so it seems like can you go in depth in terms of what the chapters are, or what was your thought, or who is the audience, or when should someone pick up this book and read this?
Sure, sure. So in terms of how to start, right? It first of all, there's a lot of literature in the media as well as journals and articles about what big data or data science is. So while that helps, it's also equally important to know how to get your foot in the door, so to speak, right? So in terms of starting it, if you're an individual who's just looking to get into big data, right? So there are two main components in terms of the technical aspect, R and Python. Those are the two of the most important programming languages that you need to be familiar with. They're not that difficult, and there are so many courses on like Coursera, edX, and other platforms from where you can learn the languages. The second is an understanding of the big data technical data mining landscape. So there's Hadoop, but Hadoop is very vast, so you really need to decide which space of Hadoop or the Hadoop ecosystem that you want to focus on. And the third aspect is, in terms of technicals, is the NoSQL aspect. So you have MongoDB, which can parse JSON. You have Redis, that's used for web-related like sharding and so on. And then there are other NoSQL databases that are much more task-specific, like KDB Plus and so on. So that's on the technical side. The book goes through, makes an introduction on the subject, tells the user, the audience, that big data is not really a new topic as such, because the National Library of Congress has millions, hundreds of millions of books. So data has always existed. And in a way, algorithms have also existed for many years, like some of the neural networks started back in the 40s. But it's just that because today we have much more computing power, especially if, let's say, if you're on the cloud, you can spin up an instance in under like 2 minutes, and you have a 2 terabyte machine with like 100 plus cores ready for you with a pre-built image. You can just go look up like, I want a neural network or deep learning image. You just spin up the AMI and you're up and running. So anyhow, so the book is meant for people who are trying to understand the subject area, understand the technical parts. So I have both the data mining aspect as well as the machine learning aspect. And third, it's also got chapters on the management audience, because what we tend to find, working with the management groups at some of the top firms in the States, is that there's not really a clear sense of where to start or what to do about big data. There's always a corporate mandate, like the VP or the C-level is going to say we need to do big data, but then somebody in IT is tasked with bringing big data into the organization. But you have to be very careful in making your selections, because when you speak with marketers, the pitch is not going to, it might not bear out in practice. Because a marketing pitch and empirical results can be very different. So in terms of making decisions, especially if it's 6 figures or more likely 7 figures, you need to try it out with hands-on and then evaluate the product. So it's also got topics that's related to how to make management level decisions on the right tool to select.
Okay, fabulous. Now, we are moving towards this micro worker, micro economy, or gig economy, which is basically, more and more professionals are choosing to be independent. They are choosing to be their own boss, their own company. So for someone like that who's thinking of a career in big data, what would be your advice?
Right. So that's a very good question. So traditionally, in colleges or universities, you have had stats, maths, physics, and so on, which are great, but then you need a few more aspects beyond just maths or stats in order to understand the subject of big data or data science. And now, because universities haven't really had these as a core curriculum as we do today, like you have data science courses or masters in data science and so on, the space where a lot of people go in order to get their foot into the subject is Coursera or edX, surprisingly. Okay. Right? So those are the two places where there's an abundance of data science courses. And second, you can also participate in a forum called Kaggle. So Kaggle is where companies, when they have some really challenging topics, such as cancer research, genomics, they're going to put their challenges out in the public, and you're going to have thousands of data scientists competing to improve their level of accuracy on a test data set. That's the kind of hands-on experience that you need, in addition to the work or your own reading that you have also done. It's a lot of effort, because it might seem like you may just watch some videos on Coursera or edX and say that I learned it, but then you really need to do the assignments, face the challenges, do Kaggle competitions, because that's when you really understand what you need. And in order to get into the practice, having a strong foundation in the subject, both from a theoretical as well as a practical standpoint, is perhaps the most important aspect. You can easily, we speak with a lot of candidates, and oftentimes the candidates come in with experience that they've gained in their college coursework, but we don't see anything too much beyond that. So when somebody comes and says, I have participated in Kaggle and have gone all the way to the end, and this is where I ranked, and this is my GitHub repository, so you can really review the actual work, that speaks much more about the candidate's capabilities than just the what's on the resume and so on. So those are the two ways in terms of getting into the industry. And if you want to do it on your own, there's lots of machine learning projects that you can get into, but that's going to take a bit longer than getting into the field and in the workplace.
So now, having been in this field and looking at how this field is evolving, do you think, or what's your prediction? Will big data be still around? Is that a field that's on an upward trajectory, or is that something like, it's just a fad that's going to die off after a few years? Where do you think we are going?
Right, right. So I wouldn't say it's a fad. I mean, so big data is going to be there. It's just that the name's going to keep getting replaced. So and that's how the industry moves, right? So now you have cloud computing, but then you were always doing cloud computing, technically speaking, but you just didn't call it cloud computing, right? So big data was there. I would say like two years back, it was really big in the States. And now that over the last year or so, year and a half, it's started transitioning over into data science. So while you were still really talking about big data, the new terminology was data science. Then for a while it became machine learning or predictive analytics, and then there were articles from management consulting firms calling it prescriptive versus predictive, and so on and so forth, the four V's. And today it's artificial intelligence. So that's how things are evolving. But then when people are talking about artificial intelligence, they're really talking about data science. They're talking about aspects of big data, and they're talking about machine learning, because AI is actually a much, much more vast subject where you have socioeconomic factors you have to take into account. But today you can just say, I'm doing machine learning, but just call it AI, and you will fit into the trend of the day.
Okay. So, and I think, that's a very interesting point. And actually, I didn't also realize it until now that you mentioned that, it's all like, data science is there. Data science is more about making the meaning of the data. Machine learning is using that data set meaning and to help that machine to understand what's going on. And then AI, I think, is the whole broad umbrella that everything falls under it, and then giving it some intelligence to make decisions.
Right.
So, okay, cool. But that's a very nice way of you putting it in there. That that I don't think big data is going away personally, just because we are collecting vast amounts of data. Right, from everything, especially with these IoTs, the fridge, refrigerators, autonomous vehicle like Tesla and whatnot. I mean, as more and more cars are getting connected to the grid,
right.
So we're going to have data points everywhere. Right. Now, to ask you a question, we understand you're using big data in cancer research, pharma, algorithmic trading, currency trading, things like that. That's great. But for someone like, is it big data, can only large corporations and enterprises, are they the only one who benefits from big data, or are there other beneficiaries like small to medium-sized businesses? Or is that prohibitively expensive for them to not even look into it? What are your thoughts?
No, well, so I'll start with the last part. So it's not expensive because Hadoop, Hive, HBase, Cassandra, Redis, MongoDB, all of those are open source tools. So if you want it, you can just spin it up on your machine. Now, how well it would perform is a different subject, right? Now, large firms have a lot of budget to do enterprise-wide deployments, which are, of course, going to cost a lot of money, right? But then you can also use it in your day-to-day efforts. And the prime example of that being, we had people who were using Excel for their market research. Now, Excel tops out at roughly 1 million rows. Now you can run different analysis and so on, but it's still not going to be perhaps as fast as you might want it to be. If you were instead using R, you learned a bit of R programming, like how to load a CSV file or a PSV file, how to write it, how to pivot data, how to group by, aggregate, and so on. You can easily work with 10 million, 20 million, up to 1 billion rows, and it would be like in real time. So I wouldn't say so at an enterprise scale, yes, large corporations would be deploying it, but smaller firms can start out, small, get the incremental benefits, and then probably scale it up. But things like R, Python, or these open source NoSQL technologies, they don't cost anything. So if we have machines, machines and talent, that's all you really need in order to build that environment out.
So for a small business, like for example, Hubdhaka, which is a co-working space similar to the Frontier, I mean, how may we be able to leverage big data? What kind of meanings do you think, or where can we look into? with the data set that we have. Like, we have a Facebook page, we have visitors, we have the websites, and all those things. What are some? If you were in my shoe, or in my shoes, what would you be doing with that? Knowing what you know,
Right.
Where should we look into? I mean, obviously, we are not at the cancer research level. We are a small shop, or maybe big data doesn't make any sense for us. So, what are your thoughts?
Right. So in that kind of model, now I have not worked too much in that kind of space, right? But one of the things that comes to mind is social network analysis. So things like sentiment analysis. So what are people thinking? It's something very similar to, recently there has been some news around Cambridge Analytica.
Yes.
Right? And that actually came out, I believe, 6 or 7 months back in Guardian, in the newspaper, and I was quite stunned that, to the extent to which, Cambridge Analytica had done their work. So they're basically building profiles of individuals who are coming onto Facebook, clicking on likes, and understanding who these people are. And they came to a point where they said, we will know you better than you know yourself. Right? So social media or social network analysis is one aspect. So you can understand what people need and be able to leverage that sort of information. In terms of gaining more traction, so in terms of the web space, we are working with a certain client who does Google Analytics, right? And they wanted a way to run these queries in real time, just with, like, as you're typing, the screens will start updating and you'll start seeing different results. So that kind of response rates was very difficult to do with commercial technologies, or we really didn't need commercial technologies. So there are many tools for unstructured text mining where we are leveraging it, as well as with our own platform, KDB Plus. We are using it for that as well. In terms of hardware, so to answer your question, there are various different applications. It's really a matter of understanding how best you can leverage, like, social information, things that are being published in the media, articles that are coming out in the newspaper, picking out keywords from there, forming graphs or word clouds, and so on and so forth.
So I think, as I listen to you more, I feel like, someone who's in the e-commerce space, right? Someone who's selling, or someone like, not Amazon today is very big, the e-commerce, but say 5 years ago, 10 years ago, where Amazon was still a decent size, they can still use the data set, what they're selling, who's coming on the site, what they're searching, where they're going, and kind of try to find meaning out of this whole data set, rather than just looking at one KPI, which is like numbers of clicks versus numbers of orders and items shipped.
Right.
Is that a right summarization?
Yeah. So in those spaces, Amazon or Netflix and so on, you use a lot of recommender engines.
Yes.
So there's collaborative filtering, hybrid filtering, and so on, by which you try to understand. You basically create two matrices where you have the users who have liked a certain movie and the ratings they have given. And then you find similarity measures with other users who have seen similar movies, but maybe not all of them that other users who are like them have already watched. So recommenders have become extremely powerful. So you may not realize it, right? But when you're going on the web and you're searching for something on Amazon and it shows you certain products, people also like this. All that's being run through algorithms, which are constantly deciding what to display to you. It's very similar to ad marketing, right? So
Yes.
that happens in the order of milliseconds, and there's a certain cost per click or cost per impression charge. So ad exchanges are benefiting hugely from machine learning because they're looking at the cookies on your machine and trying to determine what's the best ad to serve to you. So there are many subtle ways it's getting used, and recommenders are one of the prime examples.
Okay, great. So you've been to many conferences. I know you've spoken to many conferences as well. What do you think is the industry, or what do you think other countries are? Is this how do you say? Is this a demand only in the US, or have you seen like more traction and demand and adoption in other countries as well?
Right. So I think the most profound or prevalent impression that big data has had is in the States. In Europe, it has had impact, but to a lesser extent because of data regulations. So I believe in May they're going to launch the GDPR initiative. So data is going to get even more restrictive. In the US, it's not uncommon to work with data sets that are going to be over 10 billion rows of patient insurance claims data. So every time somebody goes to see a doctor, every line item that gets generated, everything's getting recorded, and vendors sell that information. So in the US, it's been there for a pretty long time, which is why I guess Silicon Valley has seen the kind of advances it has witnessed. In other countries, I think the realization is going to take a bit of time, and it depends not only on the technical stuff, because the technology is there, you have the cloud, and you can spin up instances. It also depends on social factors or geopolitical factors and so on. So if you have access to the data, then people can do more research. If your policies restrict access, then you can't really do it. So Europe is an example where policies are very restrictive. In Asia, you do have a huge volume of information that gets used, but it's only used by very limited entities, perhaps at the government levels and other departments. You don't really see that level of free access to data as you may get here. So that's not to say you don't have access to data, you do have access, but you need to go through the right channels in order to gain it. It's not as easy as just calling up a firm and say, I want to license the data set.
Okay, great. So now, in terms of, again, going back to another example, and I think examples works best, which is like, so can you give an example where, big data was very instrumental, or big data helped overcome a challenge, or able to find a meaning in a data set that was probably that would not be possible without it?
Right. So there was one example that wasn't perhaps so commercially important, but it was one of the most interesting projects that I had done, or we had done at one of the firms. It was FDA, the Food and Drug Agency. They're always looking at symptoms or side effects that patients or consumers have after taking certain medications. So in this particular instance, the place that the company that we were doing the project for, they had received certain materials from the FDA saying that your product is causing this side effect. Let's just call it a headache. And what they had done was, so whenever somebody has a side effect or some sort of reaction, they can call up a hotline, which is the number at the back of the medication, or to a National Poison Center hotline, and report that event. So those are notes that get collected. So it's called the Federal Adverse Events Reporting System. So the FDA sent all these notes, about 5,000 to 10,000 notes, call notes that they had received, where there was a mention of a side effect or an adverse event, such as dizziness, headache, etc., and the name of a certain medication. So now I wouldn't get too much into the specifics, but what it really came down to was, if the name of the medication occurred in the same sentence as a side effect, you were sort of extrapolating that your medication caused the side effect, yes, which might not be really true, because you could say that I took medicine A and I had headache, or you could say I took medicine B and had a headache, and then I switched to medicine A, which fixed the condition. So even though medicine A occurs in the same sentence, it was not the causal factor for the, yes, headache, right? Now the company was tasked with going through all these 10,000 or so notes to understand the meaning of each sentence, and then figure out, did our medicine really cause it, or was it something else? They spent, I think, about 5 months going through about 5,000 notes. And eventually they approached us and said, is there something you can do, because we have 20,000 other notes that we need to analyze. So in NLP, there's this concept called triplet extraction, which splits a sentence into subject, object, and predicate. And what you can do is you can use an API, like Alchemy API, which if you run it through the notes, it's going to split up each sentence into subject, object, and predicate. So you would see what qualifies the headache, whether it was medicine A or whether it was medicine B. and whether medicine A was a negative factor, like it fixed that condition.
Yes.
But you can do it completely programmatically. So we went through those 5,000 notes in about 30 seconds, and now we have this entire detailed spreadsheet which says name of medication and side effect and anything else and the relationship amongst them. So that's an example. It may seem like a very trivial example, but you can imagine you have two analysts working for 5 months or 6 months trying to go through all these notes versus an algorithm doing it in 30 seconds. Now, I'm not saying you're just going to trust it blindly. Yes, you're going to do a lot of analysis on the algorithm, but then it's an example where you have directly realizable commercial benefits from using machine learning.
Right, and to that I will add, it takes about 8 to 10 years to get a drug out in the market here in the U.S. So that's a long time.
Yeah.
So it's a lot of money that gets invested in research, in getting this approved by FDA. That's number two, and number three is that sometimes, while some may say it's 5 months, but you can understand if your medicine is causing side effects that are not headaches, probably people to get cancer, people to die, or it's a life and death situation, right. You don't want to wait more than even a minute, right. 30 seconds. So, I think that shrinking the time, reducing the time, even if from 5 months, you can bring it down to a week, where, you're getting to a decision point versus 5 months, you're still reviewing the notes and, kind of analyzing them and structuring them, this and that. I think it makes a huge difference.
Right. And I would add that these are, some examples where you have quick wins. Right, so when in a company, when you're told to do a certain machine learning project, what tends to happen is that people are looking at lofty goals which are pretty difficult to achieve in a short amount of time.
Correct.
So what you need are quick wins that proves to the management that this has value. And the quick win could be something very simple. I spoke with someone who was in one of the largest pharmaceutical firms in the US, and he ran one of the advanced analytics groups, and he said we did so many projects, and our best project was the changing of the timing of an email that would go out. So instead of sending it out in the morning, we'd send it out in the afternoon so people would have time to read through it and think over it and then come in the next morning. So quick wins are very important, and that is what leads to bigger endeavors, and then you can secure more budgets that way, right? That's been one of the most important aspects of successful machine learning projects. Like you can think self-driving cars and all that's really well and good, but it takes years and years of work before you can really get there.
Yeah, I think Tesla has been doing this for 10 years,
right.
And they still have crashes here and there.
Right.
Even though Tesla says it's humans who are causing it, it does alert the humans, but still.
Right.
We are not at that level, but yes, you're right. For a business to be on board and to be able to bankroll this whole initiative, you want to show them some progress early on.
Right, and it should have measurable benefits. That's another very important factor, because you can do a project that's really interesting, and you may do a lot of work, and it could be very trendy. But then, if the business doesn't see the revenue impact of doing what you just delivered, it doesn't really get the level of attention that you need in order to make the project a success. I often say that, and the second part is the results should be realizable in a short amount of time. So if it takes you 6 months to see the benefits of or 1 year to see the benefits of the algorithm that you developed, because you're doing, tests and controls and different trials, then it starts losing traction. So as an example, last year, a company called Natarajs got approved for a deep learning algorithm from the FDA, which is very striking because the FDA approves products, devices, and medical like pills and so on. But what they had was this device which can basically analyze blood flow in a matter of about 30 seconds or so. And the same equivalent tasks takes a physical machine about an hour or more than that. Now, I don't know the specifics, but the time difference was vast. And now if we can measure that blood flow metric in 30 seconds, it means the difference between a patient living or having adverse conditions. So you can get that information very quickly rather than having to wait for that long. So that's an example where you're getting immediate benefits. The results are easily measurable because you can quickly see it. The real value was this, the algorithm got me this, and it has a direct benefit, something that you can explain to, let's say, a 10-year-old, and you can just say that, it's a blood test and we're getting the right results, which which may save the person's life.
Yes.
So, yeah.
Cool. With that, I'm gonna sign off today. Raj, again, thank you very much for coming and talking to me. I've learned a lot. There are definitely a lot of opportunities, as I understand, in big data. Big data is here to stay. However, the label that we apply may change again tomorrow, depending on what the marketeers come up with.
Right.
They're always giving it a new name. However, big data is going to say, if you are in the market to learn more about big data, or you are thinking of big data in your industry, I think this practical big data analytics book should be a go-to book, just because I found it to be very, very helpful, very well written. It's a place where you can start and continue on from there.
Sure, and I would also add the courses in Coursera or edX that I was referring to. There's one from, so those who want to learn the subject,
Yes.
right? There's one from Andrew, just called Machine Learning on Coursera. There's another one called Statistical Learning in Stanford. These are all sort of open source or MOOC courses. If you want to learn about the theoretical aspects, there's one from Caltech called Learning from Data, which is extremely useful. If you want to get more into the practicals, there's one course called CS 109 in Harvard, and the videos as well as the assignments are all available online. So it's machine learning with Python. So those are, like, amongst all the different courses I've gone through, those are the ones I found really helpful, and it's very important to persevere and do it till the end, because if you drop it halfway, and that's always, you're going to feel like that because it's going to take a lot of time, but then you don't get the full benefit of the going till the end. So,
okay. Well, thank you, Raj. Thank you, everyone, for tuning in. Again, if you are getting started with the big data field, go take the courses on Coursera and where else? edX, and get them done. If not, but I would definitely still start here, because one thing I liked is about you talk about Hadoop and how to install, where you even have, like, and I just opened this page, which is like the downloading the VM. Right.
Yeah.
Downloading the VM. So I would still start here, get it going, and then probably look at the course, because as you're doing the courses, you would need a instance to spin it off and to practice it and things like that. And then you can move into AWS or something like that.
Sure. And thank you, Sajid, for having me.
Thank you.
Thank you very much.